Hi, this is question 7 from the AQA FP4 January 2013 exam paper. For the first part of this video, I'd like you to try the question, so if you'd like to pause the video now and have a go at this question. Okay, I'm now going to give you a hint to the question. So, we're given this matrix here. We don't know what the actual matrix because we're given values of A here, and we're told that A is a real number, and we know that this matrix has three distinct eigenvalues, lambda 1, 2 and 3, with their corresponding eigenvectors. So we're told one of the eigenvectors, so we can hopefully find the corresponding eigenvalue, because what we will do is multiply this by the eigenvector, and we should end up with a multiple of this eigenvector, and that multiple will tell us what the eigenvalue is. Similarly, for part B, we would do the same thing again, and we should be able to set up equations that will help us find the value of A and the second eigenvalue. Okay, for part C, this time we're given the eigenvalue and we want to find the possible eigenvector. Well, in order to solve this, we need to use the fact that this matrix take away an eigenvalue times by the identity matrix. And we know that that's going to be equal to this here. Okay, so that's basically where we take our eigenvalue away from the leading diagonal, and we can set up this equation and hopefully work out what the possible values for x, y and z might be. Finally, for part D, D is the diagonal matrix, which is made up of the eigenvalues, and U is going to be a matrix that's made up of the corresponding eigenvectors in that order. Okay, so those are my hints. If you'd like, I'd like to pause the video now and have a go at those questions, and I will go over the answers shortly. Okay, I'm now going to go over the answers to the questions. So I'm just going to make this a little bit smaller to give myself a little bit more room to work in. I'll keep this actually, so I'll just get this out of the way over here. Okay, right, so for part A, we're given this eigenvector and we want to find the eigenvalue, so I'm now going to multiply this negative A 0 A 6 0 by the eigenvector 0 1 0, and if I multiply that out, I'm going to have the top one's going to be 0, that's going to be 6, and that's going to be 0 there. And as you can see, that's a multiple of this equation here, because it's, sorry, this vector here, so that's going to be 6. And that multiple is what our eigenvalue is, so that shows that eigenvalue 1 is going to be equal to 6. Okay. Right, part B, and we're going to do a similar thing again, and this time we're going to multiply it by this vector here, so now I'm going to multiply this by 1 0 2. That's going to be equal to negative A 0 plus 2A, so that's going to be A, and that's 0 0 0 Okay, right, so that's what we've got, and now we want to show that this is going to be a multiple of this eigenvector here. So we want to show that, and we'll call that multiple our second eigenvalue, so we want to show that's going to be a multiple of this here. Okay, so in order for this to be an eigenvector, that's going to be true there. So that means I can write this down as A must be equal to lambda 2, 0 is equal to 0, and we've also got A plus 4 is equal to 2 times lambda 2. Okay, so that tells me that the second eigenvalue must be 4, which means A must also be 4. So I'm going to write down A equals 4, and I'm also going to, even though we've not been asked to find that right now, I'm going to say that my second eigenvalue is also going to be equal to 4. Okay, part C, and I'll start part C over here. We're given that our third eigenvalue is -6, and we want to find a possible eigenvector for that. So I'm going to use this over here. So I'm going to take away my third eigenvalue from the leading diagonal to give me this bit here. So I now know that A is 4, so I've got -4 take away -6, which is +6, and I've got 0, and then I've got 4, I've got 0, and over here I'm going to have 6 take away -6, so 6 plus 6, 0, and then I've got 4, 0, and over here I've got 2 take away -6, so that's 2 plus 6. Okay, so this bit here is going to be 2, so I'm just going to change that to, I'll replace that with a 2, and this bit here is going to be 12, and this bit here is going to be 8. So just to save myself a little bit of room, I'm just going to change that to 12, and that's going to be 8. And I know that if I multiply this by x, y, z, I'm going to get 0 vector. Right, okay, so if I now expand this out, I've got 2x plus 0y plus 4z is equal to 0, so 2x plus 4z is equal to 0. I've also got 0x plus 12y plus 0z is equal to 0, so 12y is going to be equal to 0, and I've also got 4x plus 0y plus 8z is equal to 0, and it might spot that the last equation and the first equation are essentially the same. So y is always going to be 0 according to this, so I can start off by saying that vector 3 is going to be, well, that's got to be 0 there, and 2x plus 4z is going to be equal to 0, so I could choose my x value to be -2 and my z value to be 1, and that's going to make that work. So my third possible eigenvector, and we call it a possible eigenvector because remember it can be any multiple of this, is going to be -2, 0 and 1. Okay, finally part D, so I'm just going to tidy up a little bit. Okay, for D we want to, if it can be expressed in this form here, we want to find the diagonal matrix D, and we want to find the matrix U. So our diagonal matrix is going to be made up of lambda 1, lambda 2 and lambda 3 along the leading diagonal, so that's going to be 6, 0, 0, and we're going to have lost it there, 0, 4, 0, and we're going to have 0, 0, -6. Okay, so that's going to be our diagonal matrix D. Okay, and U, well, that's going to be made up of our eigenvectors that correspond with these eigenvalues. So eigenvector 1 is going to be 0, 1, 0, so we've had that. Eigenvector 2 was 1, 0, 2, and we worked out eigenvector 3 ourselves. It's going to be -2, 0, 1. Okay, and that's all we've been asked to do actually. Usually we would go on and find the inverse of U and you know, write it out in full, but we're only asked to write down the possible matrices of D and U, so this is one possible set of matrices that will work. Okay, hopefully that's been fairly clear. Thanks for joining me for this video, and I hope to see you again soon. Actually, I almost forgot before I finished. I wanted to give a quick shout out to Eddie Cracknell. Eddie, you're a superstar. Thank you. See you soon.